Swayam Prabha. Digital India. Educated India.
Good morning. So in the last lecture, when I concluded, I was discussing about the appraisal template, in which the teamwork is going to assist in getting the final results as required. So now I have come back to this set of analysis. I will give a brief description of each of the analysis and why it is to be done. Then I will go into the detail of each, not necessarily for the same great detail for each one of them. I will just try to find out that wherever I have to focus a little more. Okay. The vicinity analysis, which I have already discussed in detail in my last lecture. Land use analysis, in which you are trying to find out that in that particular given site, what is the existing land use over there. It may be residential. Common land use parameters are whether it is residential land use or commercial land use or industrial land use, or there is a water body, or there is some services land use, or is it open field, or is it a structured open field, it is unorganized open field, is it a forest. So such land use items will be also the category of lands. What kind of category? First category of land, second category of land. So that is going to come within it. Then another analysis is the physical features like utilities and services lines. This is very critical. Means I am sure whoever amongst you are practically working on this project, you must have seen that the utilities and services line becomes a very strong factor for many of your decisions. Example, a site, a landscape site with an access road from here, and there you have found that there is a high tension line passing through. You have got all the information, but additionally this information is required for you, and you have found that there is a pylon here, there is a pylon here, and there is a pylon just outside your property. You are analyzing this. When you are analyzing this in terms of physical features, you will find that these services lines which are running for a kind of general landscape project that we are discussing about, they have these lines which are of trunk in nature. Trunk means this is a grid. For electrical lines, if it is a grid which is serving very other regional adjoining areas. But only thing is, eventually this is passing through your site. So you have to take information on this and analyze its potential threats, limitations, all these. Okay. And next analysis is contour analysis. In that, basically what you are trying to find out is the levels. Contour level 1, next, and next, and the profile. So it's a planned profile of the contour drawing. I am just drawing on this part of the drawing. Say it is these contour lines. These contour lines and the levels. If suppose this is level, say 5, 4, 3, 2, 1 and 0, this is the lowest level, then higher 1 meter, 2 meter above 0. So 1 meter, the next 1 meter, next 1 meter, next 1 meter, next 1 meter. It will give me a very clear idea that this is sloping in this direction. Okay. So the contour analysis has some reasons for doing that analysis. This is a contour drawing, but why you should do it, I will come to that when I will discuss about each of them. Then the slope analysis. Contour analysis, you are trying to find out the levels, corresponding levels. And in the slope analysis, basically what you are doing is you are trying to find out that what is a slope, what is a gradient. Okay. That also has reasons. Why should you do that analysis? I will discuss individually. Hydrology analysis, you are trying to find out the subsurficial water conditions, and in the drainage analysis you are trying to find out the superficial hydrological conditions over the surface. In geological based analysis, you are trying to find out subsoil quality characteristics. In the soil analysis, you are trying to find out the topsoil characteristics. In the agricultural analysis, you are trying to find out the agricultural potential of that particular land. And in the vegetation analysis, you are trying to find out the vegetative potential of that particular land. Climate analysis is that how it is susceptible to the climatic variations or exposure. In the visual analysis, you are trying to find out what good visual quality it has, and then in local regulation and bylaws, you are trying to find out that what are the restrictions that you do within this. Okay, that is how it is. If I go a little farther, it's not necessary that they will be appearing in my list in the same order, because they are not in order. They are not in order of importance. So, they may be appearing the way it is arranged. Okay, the vicinity analysis. In this, look at this. Suppose this is your site, then with respect to this, all other aspects that is around. If there is a river which is passing by, then where the river is coming from, where it is entering and where it is going to, and then what is the fate of this particular river at the edge, at the end. That is how it has to be seen. If there is a road, then how it is connected. Is it connected through a populated area and then ultimately connected to this your site? So, in the vicinity, basically you are trying to see the whole thing with respect to the surrounding areas. Okay. And this is another example. See, basically what I have done is different references and books, they have different small examples which can be best represented or cited here as a fairly good example. I have only picked up that from different books. In my reference list, finally when it is going to come, all these are going to be listed. But at least what I remember over here is the landscape design and site analysis by Hervé Rubenstein. It has many of the pictures are taken from, cited from there. And also there is another book called Handbook of Urban Landscape by Cliff Tandy. Some of the illustrations are borrowed from there, because they have very categorically illustrated it. Not that the illustration is fully complete with respect to the way I am discussing with you, but I have picked up those essentially so that I can correlate with respect to what I am discussing. So, in the vicinity analysis, if I go to the earlier one, this is the spot that you are trying to solve and you are trying to take the information for the rest. In this is the site which is yours, and the rest of the areas you are trying to find out what is where, what and where. Okay. Then you are likely to find out the general features. See, all these illustrations of different sites, only thing is it is corresponding to what we are trying to do. Okay. In this, what you are trying to say is the vehicular circulation. You are trying to find out the railway circulation. You are trying to find out the water ways by which it can be linked. You are trying to find out whether there is any low density housing, high density housing, slums or whatever. You are trying to find out that whether it has the water surfaces. So, basically all the features, general features, whatever features, you make a list of whatever different features and try to find out what features are existing within the site, and they are the things which are to be listed here and to be represented. So, this particular legend is not complete, not exhaustive. In your appraisal template that I have shown, in which all those have to be shown. Okay. Then comes the land use analysis. In this land use analysis, see, this particular land use analysis is essentially for different kind of more agricultural as well as industrial. I am just drawing your attention to one particular part. Let us say whatever is marked as 7, whatever is this particular legend or this kind of representation, I am trying to see where is it in my picture, this part. See, this legend marked 7, this part where my cursor is running now, this particular part is industry. Okay. Let us see derelict land 4 is this cross. Where is this cross? 4 I am trying to find out, maybe a very small zone somewhere, not much, maybe a small area which is a derelict land. Okay. Then say here wheat or barley, that means this is the area which is cultivated with Wittenberg, what is this number? 2 is this. So large area. Now if I try to see the residential area, what is land use of this particular area, this is a cultivable land. And suppose this is your site, then all these you have to take into consideration. Land use you take into consideration to judge whether the land use can be changed. See, prime focus of your this particular activity is when client has come to you, he has come with a request that I have to develop a landscape design for him, and he knows that that particular area is having some other land use which is non-landscape. But the thing is, he is going to check it with respect to the law and regulations, that which I have listed at the end, that whether this is convertible, whether the land use which is existing can be changed to another landscape kind of land use. So the thing is, you must thoroughly inspect or review and examine the land use characteristics. Then check with the local regulations that whether you would be permitted to go for changing this land use. This exercise should be done much before you start any other analysis, because if you find that the site which has been brought to you by a client and which you are likely to develop for him is subjected to some kind of sub judice with respect to non-convertibility of that particular land to other land use which you are thinking, in such case all your exercise and your time spent, money spent, everything will be lost. So the point is this, you take care, check with the land use. Now how do you do it? Get the land use plan, check with the local authority that whether the land use plan which whatever is existing is convertible to the kind of land use that you are now thinking, because basically by landscaping simply is not the pattern making game. I said you are changing the land use. An area which was, an example let me give you, suppose derelict land. What is the derelict land? Derelict land is that particular parcel of land which has become unusable now, but the land remains unusable now. Unusable because of many reasons, either it has lost its fertility, or it has lost its the depth or topsoil quality because of the extraction or quarrying from there. Whatever reason, it has become derelict, less usable or unusable land. The client comes to you with the plea that please design a landscape for me even if it has become derelict. The first thing that you have to check whether that derelict land is subjected to any kind of legal restrictions. Can you convert that derelict land to a landscape project site? So the land use analysis is going to give you that idea. In the whole design process, when you are going to take these decisions, for each one of them, one suggestion you keep, my suggestion, you take it very seriously. If you are checking with respect to, or if you are analyzing with respect to land use, then you must shut your all analysis for the rest. At this point, you are focusing only on the land use analysis. You are not checking the slope, you are not checking the contour, you are not checking the hydrology, you are not checking anything else. You are checking only land use. So the idea of this analysis is that you should shut off from all other analysis, focus on this analysis, and whatever transpires from this analysis, write it down in inference. You might find that inference may be a conflicting with another analysis's inference, but that will be resolved later. Don't get guided or biased because of the conflicting nature of inferences between two different analyses. If you don't do this, then what will happen is you will never be able to take a decision, because finally the decision will be whichever offers me the maximum possible opportunities, I will select that. Okay? So the land use analysis that you do. In this land use analysis, when you are doing, find out all these and check with the law. One second. Okay. Slope analysis. Before that, I would suggest that you do contour analysis. What is that contour analysis? Let me explain. For which I will take help of one of my predetermined drawing. Okay. You will see that this particular drawing is what you have seen in the screen before. Follow the line that I am drawing here. Contour analysis drawing See, your base drawing has provided with you the entire contour extrapolated, interpolated. So, I am just drawing few of the lines to give you an idea. Say this particular drawing which I have picked up, these are the contour lines. I am not drawing any more much, okay, just to give an idea. Now, you can, if you follow the drawing, you will definitely can make out where the contour lines are going to, but I will focus your attention to something else. Okay. If you take a screenshot of this and draw all the lines, you can always see what is a contour line. In this drawing, if you see that there is no levels given here, the levels deliberately has not been put in this particular drawing to make you aware of the contours interpretation. I will draw one more line for your clarity of thoughts. If suppose in this drawing, take these two lines, if this is lower, then it is sloping in this direction. If this is lower, then sloping in this direction. I think that is very clear. But if it is sloping in this direction, the curve is outward. If it is sloping in this direction, then the curve is inward. This is important to be noted. Now, how do you go for this contour analysis and what it will give you? Contour analysis, if suppose in which you make a legend, specific legend for this, where every level is drawn on this particular box, and each level, each of these contour plates has different color. An example, let me show you on this. Say this one is yellow color. This plate, wherever it is going to, is the yellow color, and the other plate is a pink color with whatever available colors I do have. Okay. Now, the moment you look at the whole drawing, where if suppose this level which is supposed to go like this and I'm here and also came here, then as soon as you see pink entering into your sight again somewhere here, then you know that this elevation and this elevation is same. That is the idea. So, the contour analysis gives you an idea of plate and its relative level across the entire site. When you know this, then you understand that if I have to think about putting something at this level and then corresponding level is somewhere here, then in that case if I do have to connect, then I have to negotiate so much of differences from changes from here to here. Few things which you have to keep in mind. Technically, contour lines generally don't cross each other, one another. No, contour lines generally don't cross. When I am saying generally, then there must be some exceptions. Contour lines generally don't cross each other. If they do cross, then either it is corresponding to the levels changing and entering into the others, or else there is a mistake in the drawing. I will just clarify that particular point a little more. It is important to be understood. We say that contour lines don't merge, contour lines don't cross, but if suppose I will draw two situations. There is a contour line going. This is high to low. Okay, look at this. If suppose this contour line has gone in and came out like this, then it is contrary to what we are saying in general. The contour lines don't cross, don't merge. Contour lines has crossed. I am drawing another example. Contour line is merged, actually, unless there is a mistake, this thing should not happen. But if it happens, then first if you see that it's not wrong, it's not a mistake, then there must be some reason for which it has happened. When this thing will happen, when this thing will merge, if suppose one contour level, then the next contour, and the one contour comes here and then merges with this, that means there is a verticality. So there is a drop from this particular level to the lower level. So there is a vertical phase. Keep that in mind in the contour analysis. And if it is entering into this, then there must be a cave, that this is overhanging, the lower level contour has entered into it as a cave. So this is cave situation. This, if you understand, then your contour interpretation will be very, very effective. And I'll tell you very frankly, contour interpretation is one of the common errors I have found amongst many of the designers. See, it is not that they are not educated about it. Only thing is they have less of exposure or practice or analysis on this. So once you do this contour analysis, in that what you are trying to find out is this. Now the process. In that contour analysis, what you have done is you have tried to find out the differential elevation levels, and now you have a set of functions which you have already listed, the set of functions which the client has requested, or you jointly have worked out that I have these functions. Let me just cite few functions here for your understanding. In this particular site, landscape site, I am trying to create it as a tourist resort. So tourist resort will have some functions like cottages, functions like road, functions like steps, pathways, water lines, sewer lines, and such. Now based on the contour analysis, what you are doing is you are trying to decide that what should be best fitting in terms of elevation. If it is water line, let us say in the water line, the line comes from the municipal road. Here in this particular drawing, you will find that this is a municipal road. Mind it, this is a hypothetical drawing, municipal road. And if I say, without writing the levels, that this is the higher altitude, that means this road is going down the slope. So it is sloped like this, okay, going down the slope like this. Okay, so if it is sloping, coming to this particular level, now this is a high point, this is a low point. I won't say whether this is the lowest point, but if I do see in this particular drawing where if this is the higher point and this is a lower point, then many of the lower levels are ultimately concentrating at this particular point. Then I might think that if the levels are changing and ultimately coming to one particular area where it is almost concentrating around a particular domain, then probably this is the lowest point. If there is a lowest point, then I would say that if there is a lowest point, then probably all the water is likely to go there. And if I want that in my tourist resort I should have a small boating lake, then probably this is the best possible area which I will select. So my first selection that I do is for boating, a small lake which was non-existent, you added. Then the next, another example, let me take it. In this particular site, you need to have water supply which will come from the municipal supply and then which will be stored in an overhead tank. And the overhead tank which should be located in your site at the highest elevation, so that once it reaches that particular point, then after by gravity it will be distributing to the entire areas. So what is the best possible location for the overhead tank? See, the criteria for selection of the site for overhead tank is nearest to the entry point of the municipal connection from the municipal limit to your site. Number one. Number two is it should be at the highest elevation. So if I take these two into consideration, then I do find that this is a particular area which is nearest to the road as well as highest altitude. And if I follow the same contours over here, I do see that this is quite at the lower level. So if I take this particular position nearest to the road and municipal water supply is coming to this particular point and keep it in the overhead tank, then I have to probably pump the water to the higher elevation to the other functional areas. So my best possible location is this. Now it may so happen that in this case, okay, overhead tank, the best location is this. Then comes, if this is the overhead tank location, and where should be my position of the cottages. Now cottages, where, how do you locate? Cottages you locate with the best accessibility. Here if I find that on this particular, from this particular edge, every part of this particular edge is equal potential for accessibility, but since this is the lowest point, if I have the access to the site from this particular point, then one has to go all along. Suppose I have decided that this is the best location for my cottages and this is the best location for my entry point because of the accessibility and all these things, then the accessibility has to maintain in such a way that this has to go up the hill to reach this particular spot. Why I have selected this particular spot for cottages? Probably that this is the best location from where I have a best look to the something, some water body or hill which is far away from my site, and this is probably the best location. So my positioning of the cottages are fairly done, but all these you are doing only at the analytical level. You are not taking decisions because this is one option. Mind it, in the whole analysis you may have 2-3 alternative options in the same site for the same function. An example, in this particular diagram it is not, but if suppose the overhead tank, this is the highest point, there could have been also a highest point here. If suppose the contour was going like this, that this particular contour line was going like this, and so all these contour lines gradually rising at this point, so at maybe at this particular point level would have been achieved, almost attained with respect to the same level. So in that case probably this was the best location, also an alternative location for the overhead tank. So once you do this, don't bother about anything else, only the contour. So the contour connectivity, when you are seeing with respect to this, you will find that there will be alternate locations for various functions. Now if suppose you have, say, example 1, 2, 3, 4, 5, 6 functions. I am just trying to draw cottage, road, lake, overhead tank, orchards, and a play field. I have deliberately done it. So these are the 6 functions which I find to be the prime in this particular site. Then in this, cottage location will be done depending on few factors. In terms of contour, which is the best elevation point from where I can see the other surrounding vicinity, other visual potential thing in the vicinity. So accordingly this is the location. This may not be good for other analysis, but this is the location at this moment for the contour analysis, so this is done. Then the road, I have to connect. The best possible connectivity to this particular cottage is from the same level. So what happens is, if this is true and then this is the particular level, this contour which runs in this direction and ultimately matches with this cottage, if this is true, then this is the best possible position by which I can have my access road. Then lake, here the lowest point in the whole site, this is the lake. Then overhead tank, the highest point in the whole site, this is the point. The orchards can be anywhere. It does not become very critical in terms of its contours. It may be critical in terms of slope, but may not be for contour. So it can be anywhere where you think can be done. The playfield, when you are placing, you will try to find out which area has the maximum amount of the same plane. So in this particular drawing I have found that with respect to scale, say this is the area which is having the same plane, or this is the area which is having the same plane. So now I have a problem. The problem is that I have 2 options of playfield. One is this area for playfield, another is this area for playfield. My suggestion is, don't get disturbed, keep both at the time being, that this could be a solution or alternately this could be a place. This is the lake. So now let me write it down in terms of these 6 functions that I have thought. This is lake, this is cottage, this is playfield, overhead tank, and the road. This is how you have done. Once you have done this, if you want to take any decision in terms of design criteria, then list them in that same template of the contour analysis. The template I am going back again to show you that in this particular template what happens is that in the appraisal template here it will be written as contour analysis, and after that you will decide that what are the common legends are there already in the drawing and what specific legends like cell levels, contours and all these things that you will write here, and then you will infer. The inference is that overhead tank has to be placed at the highest level, the water body has to be placed at the lowest level. These are all inferences, and as soon as you do this, then the design criteria for the overhead tank is overhead tank should be placed at the highest level is here in the inference, but it has to be nearest to the entry point from the municipal water supply. And once you do this, then you check in the checklist, check the entry point, and then when you plan, you check whether you have checked the entry point, has it conformed to the highest elevation, has it conformed to the easy connectivity, has it conformed to the highest elevation for which the distribution is almost trouble free. These things here are the compliance level. This is how you do it. Okay, I hope this idea is now clear to you that how really we work it out. Okay, now once the contour analysis is over, then now I am coming to the slope analysis. Slope analysis basically has nothing to do with the contour elevations. It is the relative slope between two contour lines. I will explain this in my next discussion with respect to differentiating between the contours and this. Thank you.